All right, folks. So now we've started Visual Studio Code, following the instructions in our lab book. And now we have access to our workbook right there. So let's go do this. So welcome to the wonderful world of Python programming. This lab workbook will guide you through the foundational concepts of Python programming, which later on we will lead up to. So some further work we'll do on this in future classes. So later on, future work. This will lead us up to doing the skills of Python data analysis for HR or other business domains. And then we're also going to see how to use Python inside Excel to amp up Excel's ability to do data analysis. Go and revisit our earlier work on Power BI, and we're going to see how to use Python to create custom visuals in Power BI. So there's a lot we can do here, so let's get to work. So everything in programming starts with the concept of a variable. And maybe I should make a little mind map here so we can have a visual as we're going along to keep everything in perspective. And what I'm about to say now will apply to every programming language. So if you want to get into using Java or Haskell or anything else, it's all going to be exactly the same. So there's two basic things we have in any programming language, which are variables. We have data, right? We have to be able to handle data. And this is with variables. And a couple of things we can do with variables. We can assign to variables. And we can do variable comparisons to control flow of execution in for loops, while loops, and if-then statements. In addition to handling data, we also have to handle flow of control. So that's from the beginning of the program till the end when it exits after doing its work. And we're going to see our basic structures for flow of control include if-then statements, we have switch statements and oh yeah, we have switch statements, switch cases, and we have loops, which could be for loops or while loops. And remember that for our flow of control, we're going to appeal back to our variables. We're going to do variable comparisons to decide if something should happen or not. Another element here in flow of control is reusable blocks of code, which are called functions. In object-oriented languages like Java, they're methods. Here we just call them functions. Now, when we do programming, we do a certain procedure. So here's our procedure of how we do programming. First of all, we need a way to write the program code. So we write some code, and we need an editor or a tool set to do that. So for us, that's going to be Visual Studio Code. Sometimes that's called syntax, just like in grammar. Syntax is the words of a language. So sometimes we say that writing the program code is writing the syntax. And we need an editor to do that. And our editor is going to be Visual Studio Code. Now the code goes into files. So we're going to save the files on the file system and run them under the Python interpreter. My purpose in teaching you these elementary concepts is sometimes when people learn programming, the instructor kind of bundles together too many concepts into one box, and students are confused because they start hearing about all these things and they don't know what it means. So we're going to just do a little bit of a prelude here, a little bit of an introduction to sort of unpacking some of the terminology. So when you encounter it, at least it won't be the first time you're seeing it. Right, so then we execute, or we run the code in the Python interpreter. So Python takes our code and turns it into a format that the operating system can run as a program. When you installed Anaconda Python, that is our Python environment. You can check that your Anaconda Python is working by opening a command terminal. And if you type Python, you should see something that looks like this. And that tells you that you have your Python, your Anaconda installation, and there's the version number. So that's what we're going to do. So next, we're going to go to Visual Studio Code, write some syntax. We're going to execute it, and then we're going to see the results, and we're going to keep building up until soon we will all be very experienced and competent data analytics, informatics report generators using Python. Now, some of the other things we're going to do besides writing the code, we're also going to need to have something called a debugger, but we'll get to that later, not too much at once. So once we get our code in a file, we execute it and the code runs and does the algorithm, and that's pretty much it. All right, so let's go and get started on making this happen now. So now we said that in Python, a variable can be used to store data that we can manipulate throughout the program. So step one now in working with variables. So let's get started on that, which is the first element of our learning roadmap. All right, so here's our workbook, and the better if you retype the code, but I don't know, in class right now, if we were in a physical classroom, I'd give you this on paper and make you retype it. But for right now, it's enough to just copy and paste. So we're going to take X, and X is a variable name in this case. X could be anything. So we have a numeric variable called X and a string variable called Alice. So let's go over to our Python program now and make a couple of variables. So first of all, we said that we need a file to put our code into. So let's make a file on the file system in Visual Studio Code. So file, new file. Oh, by the way, there's a couple of things you need to do to set up your Visual Studio Code for maximum comfort. So let's take a couple of seconds to do that now. Let's go back to our instruction workbook, which is my blog article on this. Right, so we did all of that, but there's something here about configuring Anaconda to work with Visual Studio Code, because Visual Studio Code and Anaconda are both best of the best, top of the world, used in businesses all over the world. So they have very good support for each other. So we're going to go now and set up our Visual Studio Code environment. Download and install Visual Studio Code. Done. On first launch, you'll see an extension icon in the sidebar. Click on it and search for Python extension by Microsoft and install it. And also, let's search for and install the Anaconda extension pack for better integration. So follow me now, and I'm going to do this. So let's go back to Visual Studio Code. And we observe over here, we have a number of icons on the left menu bar. Right? I don't see any questions or comments so far, so I guess everybody's doing pretty good. So the first extension we have is our Explorer. That's like the File Explorer in Mac or Windows. That just lets you view your files. So first, I guess we better probably make a file. I think so. So let's right click and say new. I thought I made a file. I didn't. Okay, well, let's do it now. Actually, let's go and install our extensions first, because then Visual Studio Code will have the linting to know how to handle the file. So next we can search, right? We have an ability to search for files or text in files. We have source control if we want to hook ourselves up to GitHub. We have a debugger. I love the debugger. It's great. And this is what I want right now, which is the extensions marketplace. So let's go and search for Python. And I already have a number of these installed, so I don't have the option to install them because I've already installed them. But you're going to go ahead and click install on Python extensions pack. I mean, get all of them. It doesn't cost anything. Get Python extensions, Python extended, Python snippets. We're going to get into testing later. Let's not get testing right now. And that's probably it. I guess that's all of them. So just grab whatever looks interesting to you in terms of Python extensions and install them. Now, after that, the next thing we want to get is the Anaconda extension pack. So let's go and get that. So go up to here to search and type Anaconda. Where is it? Interesting. It might be available in another CPAN somewhere. I'll go and find that out later on. So for right now, we'll live without Anaconda. I don't know where it is. Maybe it's been relocated or something, but let's skip over that for right now. Anyway, I'll find it later. Let's just skip over it for right now. Anyway, let's go and start writing our program now. So go up to here to the File Explorer and right click and say New File. And type in the name. You can just call it First Program. But this is very important. Doesn't matter what you call it, but give it the extension of .py. Do you see how when we gave it the extension of .py, that little picture of the Python snake? Yeah, that's the symbol of Python. That popped over there. So that tells us the linting. Now, linting is a language parser and a language server. So our language server is Python, and the linter, which is provided by the IDE, the Integrated Development Environment of Visual Studio Code, is going to jump in there and help us out. It's going to give us color highlighting of keywords, recommend keyword completion, and do a bunch of other cool stuff. So just press the Enter key. And now you see here we're in an environment. Because I just did some reconfiguration on my system. Well, I don't really actually need the PyDev extension right now anyway. Say automatically download, I'll let it take care of that. So anyway, now we're ready to go and start writing some code. So join me and let's do that. So we were talking about variables. Now, some of you might have experience in other languages like JavaScript, for example. You have to use let or var. Java, you have to say int or string. Python is a weakly typed language. It's an inferentially typed language. The Python language server will just sort of guess from the context what kind of a variable it is. So let's make some variables so we can use them in a few minutes. So we'll say x equals 5. And there is no semicolon in Python. I might put it because I'm used to from other languages, but there's none here. And then we'll say name equals Joe. And then we'll say, is it real? And then we can say true. You see true, Boolean can be another type of language variable. So that's enough for right now. So now we've declared some variables. So that's good. And now let's print out some of our variables just to get our program to demonstrate doing something. So I'll say print x. I know that's not a very complicated program, but it's good enough to do the job for right now. Now you see my linter is jumping in and suggesting things I might want to do there. But how do we run our program? So let's say save. Now you notice the 1 there. That's the editor's way of telling me I have one unsaved file change. So file save. And now I have to open a terminal, just like my command terminal in my operating system. Right? I can get a command terminal inside Visual Studio Code. So I go and say view terminal. I could also make a new terminal here. Could do it either way. Now here I have an output. That's going to show me my output. That's going to show me my debugger if I want to run a debug expression. And here's my terminal. Here's where I type commands. So here I say Python. And then I say the name of my program. And because this is PowerShell, you have to prefix it with period \. That's just a PowerShell thing. Deal with it. Don't ask why. It's just the way it is. And now let's type the name of our program, which is first program.py. And it correctly told us that that's 5. All right, very good. So congratulations, you've now written your first Python program. Good. All right, now let's go on to the next step of our drill. Declare two variables with various values. All right, well, we've already done that. Variable comparison. Variables can be compared using comparison operators, and the result will be true or false, and that will actually be important later on because we're going to have to determine whether a certain flow of execution should happen or not. So let's declare a couple of numeric variables. So I already have X. So now it doesn't have to be a single letter, right? It could even be a string. And now I want to evaluate the occurrence. I want to do a comparison on those. So I can say X is greater than my favorite number. And that could be either true or false. And in this case, 5 is greater than 7. So we expect the answer to be true. Oh, sorry, 5 greater than 7 is false. Sorry, guys, I need some stronger coffee here. Yeah, 5 greater than 7 is definitely not true in the arithmetic system of this universe. So save. And let's run. Now, here's a little trick. I can press on the up arrow key in my terminal to repeat my previous command, so that saves a bit of typing. Now press enter. Oh, and I forgot. I see I have an unbalanced bracket. So, right, that's an unbalanced bracket. So we got to go in under there and fix that. So let's go and try saving and running again. So once again, up arrow key, enter, false. Very good. So we verified that 5 is in fact not greater than 7. And we could also check for less than. Try again. True. All right, very good. Let's move on to our next drill. Okay, we've done that. Now we're going to start using our variable comparison and if-then statements. If allows you to execute a block of code if a condition is true. So here we have a variable, and then we're going to say if that variable is true, do something or not. And you notice here, the way we do an if statement in Python is different than many other languages such as Java. And the reason for this is that when Guido, I forget his last name, but he's an Italian guy. He works for Dropbox now. Guido was the guy who invented Python in the 1990s, 91, I think. And his reason when he was inventing it was he had 2 small daughters, and he wanted to teach his children programming. And most programming languages are quite convoluted because there's like very deeply nested structures. So Guido said, I'm not going to allow squiggly brackets, curly braces in my language. Everything has to just line up according to the margin because children's storybooks are lined up according to margins. And he wanted it to look safe and comfortable for his daughter. So anyway, we don't have brackets here. We specify the execution of a construct with a colon. So let's go and type that in. If x greater than 10, colon, enter. Now you see here, it said indent block because Python is a very nervous language. It's like that friend we all have, you know, the guy who's always chucking coffee and he's always like sweating and he's hysterical because things aren't happening fast enough. You know what I mean? Mr. or Mrs. Hyper Alpha, always worried about something. So Python is the same way in the sense that it has to have an indentation block for things to work. And it has to be exactly 5 characters. Don't ask why, ask Guido. He's the one who invented it and put us in this mess. All right, let's save this and try running it. true. Because X is 5. X is great. Really? Is something wrong here? Did I do something wrong? Oh, I see. That's a hard-coded answer. Well, in my case, X is 5. And 5 greater than 10. Oh, I see. You know what I'm getting here? I'm getting the result of this print statement. That's why I'm getting confused here. So I have to comment that out. Maybe I want it later. So let's practice using comments, which in the case of Java is the hashtag symbol. Let's try this again. So first of all, I'm going to clear my terminal. So I'll say CLS. And I'll save because I got one unsaved change there. And I'll up arrow key myself into repeating the previous command and enter. Now, in this case, we're not getting any output. Why? Because since 5 is not greater than 10, that line is never being executed. All right, let's go on to our next command now. Now, we could also have another operator which is greater than or equal to. So we'll get back to that later, but just remember, you could say equal to, greater than or equal to. All right, we've already seen that. All right, guys, let's give ourselves a little bit of a break. It is 10:10. Let's give it a break until, I guess, 10:25. Then we'll come back and we'll carry on. So on break, resume at 10:25. All right, guys, so we're now going to carry on to the next level of our investigation of Python here. This might be a construct of how we would do some implementation of some business logic with if, then, else. So let's get that running. All right, so save and run. You're pretty familiar with this by now, I guess. So somebody who's 25 is an adult, right? So that's just the example of the if, then, else statement. Now let's take a quick look at the debug console here. These programs are very simple, of course, but when we get to more involved programs, we might be in the middle of something and we're not sure what's going on. So we could use the debug console and we could ask, for example, to reveal some details of what's going on with some of our variables. So let's say I did a debug here. I can drop some debug points at various levels of my program by clicking in the left column over there. And then I could run in the debugger. So I could click on run and debug. And I want to debug Python in this case. You need to select a Python interpreter. Start. Oh, yeah, I've still got my problem with Java. All right, anyway, we'll get into the debugger later on. So right now, I'm just going to terminate my debugger and we'll keep going with our code drills. So as you can see, you need to have some familiarity with your basic computer system stuff, what's going on with your programs on your file system and so on. Now I'm using Anaconda 3 right now, so that's my interpreter. However, I'm not going to get into debugging right now. All right, so let's carry on. Right, there's an explanation if you want to get more details on how this is doing the job. Now, another way we can handle a variety of conditions, if you had a bunch of stuff to look at, it might be too much to say if this, then that, then that, then that, and so on. So in that case, we could use the fabulous switch statement. So let's grab this code. Now we're also introducing another concept here, which is a function, right? That's a function. So we're using the keyword def, and we're going to get into more function drills later on. But here we're defining a reusable block of code, which is a function. With the use of the def keyword in Python. All right, so let's run this. Save and run. And in this case, it's correctly figured out that if we feed in day 2, that's Tuesday. What if we gave it a value that was not there? Well, in this case, it's simply reporting that it's an invalid day, because if we ask for something that's not there, it's going to default down to that. All right, next activity. Create a switch case function for the first 3 months of the year. If the input is 1, it should return January and so on. All right, so let's just, I mean, that's basically the same as what we already did, but let's just get more reinforcement on that. Save and run. And the second month is in fact February, so yeah, that makes sense. Now, you see here we're using another thing which you have not previously seen. We're saying months equal, and then we have some stuff between the curly braces. Where's my screen capture tool? Right, so here we're observing a reusable block of code, which is a function. And because this is Python and it uses indenting, the Python is everything to try that again, Peter. Everything defined between the open and closing curly brace. And then we're returning months.get. Now that's another construct you haven't seen yet, but months is referring to an array. So this is an array in this case. It's a simple data structure. And we're using the dot accessor notation. And then we're using a built into Python. We didn't write it by ourselves, but we're using a function called get. And we're passing into that month. And in this case, if it's not valid, it'll return that it's invalid. So if we do get something, if we find a match in here, we will never get to that return statement. It'll just return this. However, if it asks for some, if it falls through all of that without finding a match from any number, then it'll return that. Otherwise, it will correctly return the result of whatever you asked for. So a couple of things going on here, a function call, or sorry, a function definition. We're defining a function. We're invoking the function down here. So there's our function invocation right there, wrapped up in a print statement. So it'll output the result. And that's about it. So a few things going on here, but we're going to build them up in little bits. And then eventually, within a couple of weeks, we'll be quite familiar with all of that. The only solution for learning this stuff is to just write lots and lots of code. All right, let's carry on to our next activity. Take a couple seconds to practice that. Retype it by yourself, and then we'll carry on. Okay, I just took a couple of seconds to add a detailed explanation up here of what's going on. It's what I just basically said. You can read through that later. This line defines a new function called month name, which takes a single parameter of month. The purpose of this function is to return the name of the month based on the given numeric value. Inside the function, we declare a dictionary. So that's the type of data structure we haven't seen yet. It's a dictionary. So a dictionary lives between curly braces, and it consists of key value pairs separated by a colon. So key value pairs separated by a colon. It's one of the three kinds of data structures inside Python. We'll see the other ones later. Now let's look at loops. I think we have enough time to get another 2 exercises in before we wrap it up. So let's introduce loops. Loops allow you to execute a block of code repeatedly, and it's controlled by a variable, right? So you have to have a loop controller variable. So that's one of the reasons we introduce variable comparisons is you will use loops, you will use variables and variable comparisons to control the number of times the loop is run, is executed. And now we'll say, watch out, because if you don't manage your loop controller variables properly, you may find yourself caught in an infinite loop. So here's an example. Let's get this code up and going, and then let's study what it's doing. So this is how Python does it. Other languages you might have seen in the past, you might be looking for the round brackets around the loop controller variables. This is Python. Guido doesn't like brackets. They irritate him. His ball, his rules. So that is a for loop. For I in range 3, print I. So let's see what's happening there. I'll comment this stuff out so we can come back to it in a minute. So for right now, we're going to run only this first little bit here. So we'll say save and run. 0, 1, 2. Yep. So now this is the whole number system. So it always starts in 0. However, this is an array, and arrays are 0-based indexing. So you're wondering, why didn't it go to 3? Because that range, that array of values starts with 0. So 0, 1, and 2 gives us positions 1, 2, and 3. That's just how arrays work. Deal with it. After a few times of writing some code, you'll get familiar. All right, so now let's go and run our second loop down here. So I'll uncomment this stuff. And similarly, we're getting the same effect. We're starting at 0. We're going to 1 because we're incrementing our loop counter here. Then we're going to 2. Next time around, we're going to get to 3. But here, it has to be strictly less than 3. If we said less than or equal, what do you think is going to happen now? Well, not surprisingly, now it's going all the way to 3 because it's less than or equal. All right, we have time for one more before we wrap up today's class. Actually, well, they say I should end at 10 minutes before the hour, so I think we have time for just one more, which is yeah, so here instead of going from 0 to 3, we're doing a certain range. So let's just do this one more. And then next week, we'll start up with arrays. Yes, Begu, what's up? Yes, talk. Yes, please. Thank you. I'll be there in a minute. Hang on. All right, guys. So that is an example of a basically printing over, right? We're using a for loop and we're going over a certain range. Now, next week, we're going to pick up here. So next week, we will pick up with arrays and we're going to see how we can create arrays and loop over them. And then quickly, we're going to build up to our main goal, which is data analytics. All of this stuff has been level setting you to get you up to the point where you can now start working with arrays. Right, so we're going to resume here next week. All right, guys, class is over. See you later. Have a nice week. Bye. Have a good day. Take care.